Alrighty, so this is section 1.3. We're going to talk about linear equations in two variables. So today's focus for day one is going to be on lines, so linear equations. So again, you have a lot of experience in linear equations, so we're just going to do a quick overview to make sure everybody's feeling good and remembering some of the things and how that might apply to the new functions that we talk about this year that you have never seen before. So how can we use those same strategies that work for linear equations in other formats? So here are essential questions for today, this first part. How can I use slope to graph a linear equation? So how can I use slope to graph linear equations? So this idea of slope. And then how can I find the slope of a line given 2 points on the line? So being able to calculate slope. So we're going to dig into this concept of slope, what that means. So what I'm going to have you do first is write down your own definition. So we're going to use this definition box. Write down your own definition of what do you think slope is? What are some of the things that you would use to describe slope? So go ahead and pause the video so we can talk about what that means. So go ahead and pause and see what you can come up with. All right, well, a lot of people talk about slope and they use some different terminology, but really what slope is the rate of change. So what we're looking for is how something changes. So it's giving us a measure of something. So it's a rate of change. It's telling us, a lot of people talk about steepness. So it's talking about how steep or flat a line is. But it also tells something about direction. So a lot of times people talk about what direction the line is going. Is it going up? Is it going down? Is it rising or falling? So it's telling us some good information about that. A lot of people say rise over run. Great way to remember what's happening. It is a ratio. It's a change in the vertical over a change in the horizontal. So a lot of times people will say it that way. It's a change in the vertical direction, which is usually y. So a lot of times we'll talk about that being a change in y over a change in x. So we can talk about it that way as well. So a change in the horizontal, which again is normally x, but it doesn't have to be. So rise over run, change in y over change in x. It's giving us some information about how steep, but then also the direction. So those are the things we want to dig into today. So let's talk about that. So if for a linear equation in two variables, y equals mx plus b is called linear because its graph is a line. So because when we graph it, when we make the picture, the graph is a line. So it's pretty straightforward when we think about what that means to us. So y equals mx plus b, we call that linear. And this idea of slope is a huge part of this. That constant rate of change is what makes something linear. You're always going up and over, or down and over the same amount every time. It's a constant. So that's why we have this idea of a line. That's what makes it straight, that it has this constant slope. The rise over run is always the same. If you have a positive slope, so if the slope is positive, as you go from left to right across the graph, that means it goes up. There's a lot of different ways that people say that, but it rises. It's going to be increasing. It's going to go up. What I'd like you to do is try to see if you can fill in the next few pieces of information. So I want you to pause the video, see what you remember from linear equations, and then we'll come back together. So go ahead and pause and see if you can fill in those next couple of sentences. All right, so coming back, it says a line whose slope is negative then. That means it would be doing something like this. So a lot of people, if you say rise, then you might say falls. If you said up, goes up from left to right, then you might say goes down. Whatever makes the most sense to you. Use the words that make sense. Slope intercept, we're going to be using this a lot. It's one of the most common forms of a line because it's very user-friendly, is y equals mx plus b. Slope intercept form, where m is the slope, that rate of change, and the b value is 0b. So the y-intercept. So it's telling you the y-intercept value. So you can write it as a ordered pair, like we talked about for intercepts in section 2. Some people just say the b value is, so b is equal to. Also fine, just realize that that's where it crosses the y-axis. What about vertical lines? So this is kind of an exception to the rule. A vertical line, do you remember what kind of slope it has? So think about what kind of slope does a vertical line have? So vertical lines, well, they have what we call undefined slope. So the slope, I'm going to jump down here so we can talk about this. The reason a vertical line can't be written in the form y equals mx plus b is because the slope of a vertical line is undefined. There's no number that represents it. So what would you put in for m if there's no number that can represent it? So the slope of a vertical line is undefined. We can't write it in the same way. And also, when you think about a vertical line, every single point on that line has the same x value. You always go over the same amount and then you graph your point. So when we talk about vertical lines, we're talking about something in the form x equals a number. So I'm just going to use the number symbol there, or hashtag is the more common use, but it's a number symbol. So x equals a number, like x equals 7, x equals 5. It means every single point on that line has an x value of that number. So that's the way that we express a vertical line. If it's a horizontal line, the slope is 0, and we're totally fine to use slope-intercept because then it would just be y equals. But for vertical, we definitely need to have x equals. All right, so let's talk about an example of how would you graph then. So how would you graph something using the slope and the y-intercept? So we talked about how to graph equations in the last section by making a table of values. So we could plot points. If we understand some things about linear equations, though, I don't know that we need to go to all that work to make a table if we understand y equals mx plus b. So first of all, would you agree that this is a linear equation? Always look for your x and see that it's raised to the first power. So the highest degree of x is 1. This is definitely linear. Another big hint, they said it was linear, but they won't always, right, when you're looking at your own situation. So we know it's linear. Which value represents the slope and the y-intercept? Can you go ahead and pause the video quick and write down what you think the slope and the y-intercept are? Hopefully we're in agreement that whatever's multiplied with the x is the slope, so negative 2/3, and then our b value is negative 4. So how would you go about graphing this if that's all you know? So if those are the only two pieces of information, well, we have to start with a point. How do you know how steep to make the line if you don't have a point to start with? So the only one that's really giving us a point is this second piece of information. So what we do first is we want to graph the y-intercept. So we're going to graph this y-intercept value on that graph, and we'll be able to start from somewhere. So if b equals negative 4, that means you're going through the point 0, negative 4. That's where it's crossing the y-axis. So start by graphing the y-intercept. Then we can use the slope to help us find another point. So we can use the slope to find another point. And actually, you could use it to find as many other points as you want to. But how many points do you actually have to determine a line? Well, have to have 2, right? But sometimes we do more just for insurance, but we need 2 points to determine a line. So let's take a look at what this slope is. So I'm going to write it a couple different ways. A lot of times you'll see it like this, with the negative sign just out front. In a fraction, that means the negative sign could go in the numerator, or the negative sign can go with the denominator. So let's look at the different ways of being able to represent that. Remember, this is rise over run. So let's talk about the first version, a negative 2 up top. That means the rise is negative 2. That means you're going down 2, so 1, 2, and then positive 3 would be 3 to the right, so 1, 2, 3, and the point would be right here. So we went down 2, so down 2, and then we went 3 to the right. That's one option, but we could also do it this way, just for kicks and giggles. A rise of positive 2, that would mean up 2, and then run negative 3 would be left, so 1, 2, 3, and that would be over here. So that would be up 2, and then negative 3. Well, guess what? It doesn't matter which way you do it, you're still getting a point that's going to be on that line. And you can continue to do that. Down 2 over 3, down 2 over 3, or up 2, back 3, up 2, back 3. It doesn't matter. It's going to give you points on the same line. So again, it just kind of makes sense with whatever space you're working with. If you have more graph to work with on one side or the other, you might choose one over the other. They're equivalent, though. They're points on the same line. So the idea is we don't have to make a big table of values if we know it's linear, because we can use the slope and the y-intercept. Let's talk about the special values then, or the special cases, I should say. What about vertical and horizontal? Do we even really need a whole lot to deal with those? And hopefully they'll be a little bit easier. For some reason, though, it seems like these are harder for people because they don't fit that same pattern for when we think about them. Hopefully we can alleviate some of those misconceptions here, though. Let's take a look at y equals negative 1 first. Technically, that is slope-intercept form because it's y equals. So let's think about what y equals mx plus b would say for that. If we just have y equals negative 1, I'm going to put that over here. There's no x, right? We don't have an x at all. What does that mean your slope has to be then if there's no x? Well, it must have been 0. Now, no one would probably ever write the equation that way because it's more work, but 0 times anything is just 0. So it's the same thing. That means the slope of this line is 0 and the y-intercept is negative 1. So it's definitely crossing the y-axis at negative 1. I know that. I can graph that point first. But what does a slope of 0 mean? How do you write 0 as a ratio? So think about this first. This will be helpful moving forward too. You can make any number a ratio by putting it over 1. So 0 divided by 1 is most definitely still 0. So rise over run being 0 over 1 means I don't go up or down at all, and I could go 1 to the right. And that would be another point on the line. I don't go up at all. I can go 1 to the right, and I can keep doing that. I could have had it over -1, so it doesn't make any difference. All of the points on this graph are going to have a y value of -1. So y equals a number is always a horizontal line. The rise is 0. It's not going up or down at all. That's what a slope of 0 means. So if you see y equals just a number, yep, we're going to go ahead and make a horizontal line at that value. All right, let's take a look at the second one. What about x equals 3? So x equals 3 is not in slope-intercept form. There is no y equals here at all. So what you have to be able to recognize then is that means this is a vertical line. So there is no y equals that we can look at. So will this graph ever cross the y-axis? There's no y-intercept. Well, no, because if you have a vertical line at x equals 3, you're never going to cross the y-axis. And what would the slope be? So for the slope, this is going to be undefined. The rise over run, the only way to make this happen is if you're not going left or right at all. That's what vertical means. So you'd be dividing by 0, something over 0, which we know is not going to have a value, a real number. So the rise over run, the issue why this is going to be undefined is because we're not going left or right. And again, B, there is none on this one. So there's not going to be anything. So we go through 3, and then every other point on this graph would have a same x value of 3. So you can make more points if you want. A lot of people just go over to 3 and go ahead and draw it in. So x equals a number, vertical line. Slope is undefined. There is no y-intercept. The only way you could have a y-intercept for a vertical line, any guesses? Which vertical line would it have to be? Well, it'd have to be right on the y-axis, and that would be, its y-intercepts would be every point on the line then. So that's kind of the only exception for vertical that would have a y-intercept. Otherwise, it's parallel to the y-axis, so it can't cross it. All right, so that's vertical and horizontal. So theoretically should be easier, but they can be tricky for people. So we just need to think about all the x values are equal to the same thing, vertical. All the y values are equal to the same thing, that's got to be horizontal. All right, our last little part of our essential question today was finding the slope of a line. So we're going to review a little bit about how you calculate slope. My first question for you is if you already had a graph, so I'm going to go back to this picture. If you already had a graph, would you be able to calculate the rise over run? And absolutely you would. You could take any point on the graph and you could count how far does it go up and down and how far does it go over. So down 2 over 3. And you'd be able to write out what your slope is because you can calculate rise over run from actually a picture. So if you're given a graph, like if I know a picture, I should be able to calculate the slope as long as I can tell where the points are, right? Sometimes that's hard to tell. So if I don't have actual points, that would be kind of tricky. But do I need a graph? Do I actually have to have a picture to be able to calculate rise over run? Well, no, you just need to be able to find out how much does it change vertically and horizontally. That I can just do with a calculation. So think about what is a change? If I want to figure out how much something changes, so like if my score went from a 20 to a 30, how much did my score change? Well, it changed 10, right? Well, how do you calculate 10? Well, I probably would do 30 minus 20, right? Find out the difference between the numbers. That's how we calculate change for slope as well. So if you think of slope as a change in y, and we're going to assume y and x here, knowing that those variables could be different depending on the application. So if we're thinking change in y over change in x, so that rise over run, how would you calculate that? Well, you just find the difference. And again, just like we did for distance formula, I'm going to kind of note my 2 points as point number 1 and point number 2. I'm going to use the subscripts to help keep those apart. See if you remember, I know you've done this before. What do you think you need to do to calculate slope then if those are your ordered pairs or your points? So go ahead and try to write it in if you can. So change in y, so y2 minus y1, we're going to subtract over x2 minus x1. So we find that difference. Now, here's the important thing. Always pair up y's with y's and x's with x's. One of the most common errors that people make is they just go too quickly and they grab the wrong number. So y's with y's, x's with x's. Another common error, rise over run. Rise is vertical. That means it has to be y over x. You can't do it the other way. Rise over run, that ratio of steepness has to be always looking from the y over the x. Another thing to be careful of is just your arithmetic. All right, so here, let's take a peek and see how we would do that calculation then. I'm just going to do an example. So we have a 2 and a 5. So -2, 5 is one of my xy pairs, and then my other xy pair is a 4, -3. So you have to decide which way you think is easier. So we're actually going to calculate this both ways and decide what we like best. Okay, so let's kind of highlight for ourselves what the y values are. It looks like it's the 5 and the -3. So we could do rise, so 5 minus the -3 over, okay, now we have to start with the same point then. Once you select whichever one you're going to start with, it doesn't matter which point you pick, but you've got to start with the same one then for the x's. That means we have to start with the -2, and then we have to subtract the 4. So just be super careful when you're doing that. So we could have done it that way. That's totally fine. But we also could have started with the -3. So we could have done -3 minus 5. And then we could have started with the 4 that we would have had to. 4 minus -2. Okay, I want you to pause the video quick and do the arithmetic for both of these and see what you get. All right, well, I'm hoping that you got the same answer for both. 8 over -6 for the first one, the top one, which reduces down to 4 over -3. That's the same rate of change. Up 8, and then to the left 6 is the same as going up 4 to the left 3. Look at the other one. We got -8 over 6. So the negative was just in the other location. So we're going down and then to the right. So going up and to the left is the same as going down and then to the right. Well, of course, we saw that when we graphed the other points. So either way, it doesn't matter which one you start with. Just be consistent. Start with that same value. So this is a negative slope. So again, think about what that means. This graph is falling as we go left to right. It's going down. So we can find out what that value is. So if a line falls from left to right, it has a negative slope. If the graph is horizontal, do you remember what kind of slope that has? If the graph is horizontal, that means the rise is 0. It has 0 slope. If a line is vertical, it has undefined slope. And then if the line rises, easy for me to say, it has positive slope. So just always think about those are kind of the 4 outcomes that are possible when we think about slope. So a way to be able to calculate slope from 2 points is just to do your rise over run. Now, that's not to say that you couldn't have done it by graphing. So what if I said, well, hey, I have some graph paper here. What if I do -2, 5? So I'm going to graph that point, and then 4, -3. And I'm going to think about the line that goes through those 2 points. That worked out really well. Kind of surprising. Doesn't always. Could I calculate the slope from the graph instead? So let's see if we can figure out the difference between these 2 points vertically. That didn't work out as well. So the change vertically. So I'm going to look at that distance. So let's go ahead and see if we can figure out how far would we go down. So 1, 2, 3, 4, 5, 6, 7, 8. To get down to -3, so we went down 8, and then we'd have to go over 1, 2, 3, 4, 5, 6. So rise over run would be -8 over 6. That's if I start at the top point, but I could have counted the other direction as well. So I could have gone up 8, and then 6 to the left. So I could have written it as 8 over -6, and I end up with the same exact thing. So you can count on a graph. That's great. Sometimes the points aren't going to be great to graph, though. What if they're like decimals and stuff? So if we have this formula, this way to calculate, it's just a difference. How much does it change? It makes it really easy to do. All right, so let's go back to our essential questions. How can I use slope to graph a linear equation? So being able to identify the y-intercept and the slope to be able to graph that. Or if it doesn't have a y-intercept, like those vertical lines, being able to recognize that, the special cases. So going back to those 4. So being able to do negative slope, 0 slope, horizontal, right? Undefined if it's vertical, and positive slope is a really powerful tool. Then the second part, find the slope given 2 points in a line. We have this wonderful formula, rise over run, change in y over change in x. That works great.